Okay, hello there. I'm fixing a FT-7900. The problem is when you key up the microphone, there's no audio being heard on the receiving end. So we're using this FT-60 handheld as our receiver, and this radio here can receive fine if I key this one up on the simplex frequency. I'll just show you guys here. It's 145250. And same frequency here, simplex. So if I key this one up and talk, hello 1 2 3 4 5, so that's working. But now if I listen on this one, I'll leave it turned up pretty much all the way and key this one 1 2 3 4 5, hello radio, nothing. Okay, so I got it hooked up here to an external SWR meter and also a dummy load, dummy antenna, right? So this way I can do these kind of tests. Now, first thing I did was downloaded the PDF service manual online, and then I came up with this little hand sketch drawing of what the voltages should be at the head unit here. Now I suspect that the problem is in the head unit because there was some drink spilled in it a couple years ago and it's never been the same since then, and the problem got worse, and I've tried changing the microphone, didn't do anything. Also notice that when you turn the lamp on, the microphone switch here, that none of the buttons are lighting up anymore, and they used to light up really bright. So that's another sign that the mic is not getting enough power. So let's open it up and have a look inside. Okay, welcome back to the video. This is the second part. We got our sleeves rolled up and we're ready to open up the FT-7900 and see what's going on with our voltages. Let me just get a screwdriver here and show you how this thing works. There's a little button on the side, opens up like that, and then we got this little clip part. You can take that out. I gotta remove all of these screws here. There's 1, 2, 3, 4, 5 screws that need to be removed. So this screwdriver looks a little large. Let's change the bit. Pretty straightforward stuff. I believe the screws are all the same in length and thread, so it doesn't really make much difference where they come out of, where they go back. Oops. Yeah, and they are all the same. There's one more up over here. There we go, that's the fifth one. I just came up with a screwdriver. Okay, a note to you guys at home, you may not want to use magnetic screwdrivers if you're working inside the circuitry. For outside it's not a bad thing, but once you go inside, if a magnet should touch a chip or something, it could be a big problem. So just thought I'd mention that. Okay, off comes the cover there. We'll put that aside. Now let's have a look here. Okay, all of these colorful wires, if you guys can see that. Let me try to zoom in a little bit here for you. Oh, that's as far as I can go. Okay, I'll bring it up a little bit here and we'll focus on this. Get some more lighting. Okay, all of these wires here go out to the microphone, of which we're having a problem with our voltages, pretty sure. And then this connector here goes to the base unit of the radio. So what I'm going to do is I'm going to plug in the base unit, and we're going to take some measurements off of these wires and see if we have a problem in one of the wires or if it's something to do on the circuitry. That's going to be our first test. So let's get to it. Let's turn this around this way. And very carefully power up the radio. Well, get our power back on here. There we go, 13.4 volts. Now, what we want to do, I'm going to be checking this on TX and RX, mostly on TX though. So you need the light plugged in for that. I'm just going to turn the lights out for a second here and have a look at the illumination of the microphone. I'll leave this switch on and turn out the lights. See if this is going to glow if I wiggle anything around here and with the wires, because it could just be a simple thing as a loose connection. So I'll put that down. This should glow red if it's only a loose connection, as I wiggle things around. And not seeing anything lighting up or flickering. So that's kind of telling me that it's not a loose wire or a bad connection right off the bat. Well, what we are seeing glowing here is the screen display. That's probably running off of a different part of the circuit. So we're looking at the mic buttons here to see if anything's going to glow here on the face of the microphone as I'm moving all this wiring around. And not getting anything there. No illumination here. So now it's time to take our voltage reads. Lights back on. I'm going to be using just your standard multimeter. I'm sure a lot of you guys at home got one of these. We're going to set it to, I'll put it on the 20 volt scale, DC. Make sure it's on DC, not AC. And I'll just set this, where can I set this so you guys can see it as well. Somewhere about here should work. See, this little button here goes to AC, and then this without it goes to DC. That's how I know it's on DC. And if I measure my power supply here, I can just give a little test of the meter that it is working. I'm getting 13.08 volts out of my power supply, which is powering this radio. Okay, so I know the meter's good. Now, if you remember from the first part of the video here, I got the PTT wiring, and the voltage is right here on pin number 2. Should be 9 volts. So let's figure out which is pin number 2. And we'll have one of our leads is going to go to the ground. So where's the ground, you might be wondering. Grounds are usually where the screws go in. Here, here, and here. And also here, here, and here, where they crimp the board in a holding place. So I'm just going to use this one here because it's easy to get at. Actually, this one over here. And this will be our black lead. And now I'm going to touch these pins here and see which one this is. Oh, okay, so I'm getting 4.9 volts off of the white wire. But right now I don't really know if that's SW2 or if that's the PTT line. So I got to figure out what side I'm working with. And the easiest way that I could figure that would be to put my meter into the setting that is for the ground. And then I'll test pin 5 and pin number 2 and see which side here is actually linked to ground with 0 continuity. So for that test, I'm going to shut the power off that goes to the radio, and I'll put my meter into the ohms and touch the leads together. So see, this is basically what I want to get. I want to get zeros right across, with one onto the ground and the other one onto either pin 5 or pin 2. So this is just figuring out the numbering of these pins. So okay, there's nothing over here, and there we go. Okay, I'm getting well, almost 0. Close enough. I'm satisfied. This one here is going to be pin number 5, because pin number 5, I can just get this in here. Okay, pin number 5 is actually right there, and I know that because when I go to the ground, pin 5 is ground, so ground and ground will give me a reading. Now if I go over to here, because this is the only other option where it could be, I get nothing. So I know now that this is number 2 and this is number 5. So I should be getting 9 volts off of this contact right there. I'll try to zoom in on that in a minute, but let's first turn the power back on now and test it to see. But we'll go back to our DC voltage reading there. Check the meter again, make sure that the meter is functioning. Yes, it is. Okay, so I'll go back to my ground. Radio's lit up, I know it's on. And I touch pin number 2 very carefully. Ah, look at that, I'm only getting 1.8 volts. So what I want to do now is I want to try keying the microphone. This is going to get a little tricky. I'm going to have to key it like this as I test. Pin number 2 again. And ground. I'm going to key the mic. And you can't see it, but I'm getting 5 watts out of the radio on the meter, and I'm only getting 1.5 volts even when keyed. So right there we know. Nothing to do with these wires, nothing to do with this connector, because the problem is coming off of my test point right there. So time to zoom in for you guys at home so you can see what I'm talking about. I powered off the radio. Let's power off the meter. Unplug it. And we'll come up closer here to the camera. Focus in again. There we go. So, right here, the red wire is pin number 2. And according to my little chart here, pin number 2 should be 9 volts, and it's not. So now we need to go and troubleshoot the circuitry around probably the same area, find out what has failed on us, why we're not getting 9 volts at a pin number 2. And oh, I'm losing focus on the camera, sorry about that. Let me see if I can get really close in there so I get a good picture of what I'm talking about. There we go. Okay, so red wire, test point down here on the board, only getting 1 volt, well, 1.5 volts, when it's supposed to be 9. Alright, let's pause the video, and when we come back I'll have further troubleshooting steps for you guys. Okay, here's another note. Before we go ahead checking the circuitry over here, I want to make sure that we're getting the proper voltage from the base unit into the head unit. So, tip of the day is, this is my little way of testing out this kind of a telephone style jack connector. You can't really get in there with the test points on the multimeter, it's just too large, it won't fit. So what I do is I take these little alligator clips and I clip one onto the lead here, clip the other one onto a small flat screwdriver, and then the tip of the screwdriver can fit in there just nicely to get the reading. So I check the diagram, and this is the bottom of the head unit. The bottom of the head unit is the bottom here, and it's the third pin over. So if you count 1, 2, 3, put that screwdriver in right there, and then take the ground lead and touch one of the ground spots, which is right where the screws are. I'm getting 8.79 volts, and according to the schematics I should be getting about 9 volts. So, well, that's close enough to satisfy me that it's getting sufficient voltage. It's getting 8.8, which is, you know, just a few away from 9. And if you notice as well, the lights are very bright in the head unit, so I don't think that this is lacking power coming from the base unit. But there's definitely something going on over here. So between this point and this point, we have to troubleshoot the problem now. So I'm going to pause the camera again, and we're going to go and take a look at the schematics and see what components here on the board we're going to have to troubleshoot. Alright, we're back now, and I'm going over the schematics here. This is our microphone input. I'm using this red stick here to point to my computer screen. I'm going to zoom in on this a little bit more as we go along here, but for now I can just narrate as to what this is all about here. This is the 9 volts pin number 2 that we were testing earlier. And this line comes through here, goes through a resistor here. There's a test point 2034, that's the one that we were using for testing the voltage, and we were only getting about 1.5 volts. So there's a resistor here, a 0 ohm resistor. That's resistor 2101. That, unfortunately, it's on the other side of this board. So I would have to unscrew this board, get it out of there, turn it over to test it. So before we go through all that trouble, let's see if there's something on this board that's gone bad. And how we're going to do that is by checking the voltage at another test point in the circuit. So I conveniently found another test point. If we follow this line all the way through, it goes through a capacitor here to ground, and then it goes through a couple more resistors over here, comes all the way over. I'll just scroll the image on the screen here. Comes all the way over this line here, and right there, look at that. Okay, so that, if I can zoom in a bit more, maybe I can enlarge the image as well. Now it moved on me, so okay, bring it back up center there. Test point 2024, 8.9 volts. Well, remember back when we were testing the voltage coming from the main unit into the head unit, we were getting about 8.9 volts. So that tells me that the voltage we were getting is about accurate. And this test point 2024, you might be wondering, like, where is it now on the board here, right? So in order to find that out, we have to go to another image in our schematics here. So we'll zoom out, and if we go down to the next page, look at that. There we go. We have the actual layout of the board. So I'll pull that into the camera view here, zoom in a bit more, and try to get this centered. Here we have, over here, test point 2024, right there. Okay, so if we take a look at this board in comparison to this board, we see there's the cutout there for the jack, cutout there, and the Q2011 chip is right there. So basically it's just mapping everything out so it looks identical. This is the the map image of this. So, and then there's the test point 2024 on the board right there. Now it's not numbered on the board because they couldn't print that small on here, but we know that that's the one because it looks exactly like the picture here. So I'm going to test this test point with the power coming to the radio and see if we're getting the voltage there. Then we know that the problem is from this point in the circuit going forward to the microphone jack. If we're not getting voltage there, then we have to go back even further in the circuit to see what failed. I hope that's a good explanation. So we'll pause again and we'll go back to the workbench and do another voltage check. Okay, and we're back. So now let's do our voltage check on the test point 2024. As I pointed out, is this test point right here. And if you're not sure when you're checking yours, then just rewind this video a little bit and you'll see me pointing it out and how you can easily know which one it is. So black lead onto the ground, digital multimeter set up for DC voltage, obviously, in case you don't know though. And then we'll check the test point there. And alright, we're getting voltage. We're getting 8.8 volts, and it's supposed to be somewhere in around there. So that's fantastic. Now, this tells me that the problem is from this test point in the circuit going forward to the microphone jack. And there's very few components in that circuit that can be the problem. We have some resistors, capacitors, and that's about it. Maybe a diode. So it should be an easy thing to find and replace. Small soldering for replacing, but that is what it is. So let's go back to the schematic again and now figure out which component is most likely the one that's gone bad. And I'm suspecting it may be on this side of the circuit board because of the fact that something was spilled in here. So it's probably damaged. Maybe the first resistor that's in line going to the mic jack here. It's a 0 ohm resistor, but even a 0 ohm resistor can be a big problem if it's not in the circuit, if it's shorted out or if there's a bad solder connection or something like that. So here's what we're going to do. We're going to power up the radio and go back to our schematics and see which one we're going to pick on. Alright, we are writing down with pen and paper the components we want to check. So let's go back here to our test point. This was the test point we checked. We know voltage is coming in here, so everything from this side of the circuit is good. We're getting our 8.8 volts, and this is 8.9. That's okay, I can live with 8.8. It's close enough. We want to go this way in the circuit and find out now what is stopping our 8 volts from getting over to our microphone. Let me just zoom out so we can see everything there. Alright, there we go. Focus a little bit more. Sorry for my camera ship. I'm new at YouTube here, so hopefully things will get better as I do more videos. Okay, so from 9 volts at pin number 2 that we're not getting, you have to go through all these components here. There's a resistor there, there's a capacitor there, we have 2 more resistors here, and look at that, that's it. So we have 1, 2, 3, 4 possible problems. So I'm going to write down what they are. The first one in the path is resistor number 2101. I'm getting that from right here. So what I'll do actually, seeing how this is the only area, I'll just enlarge the image, pull it up over here so maybe it's more readable for everyone at home. Okay, we got this one here, 2101. And just refocus again too. Okay, there. Now we can all see it. So we got R2101, a 0 ohm resistor. So I'm going to make my notes here on my paper. That equals 0 ohms, just like that. Okay, and then next we have C2052, and that equals 0.001. That's a capacitor that goes to ground. Then over here we have two more resistors. We have R2097 and R2098, 22 ohm resistors each. So let's write that down on our list. Probably wondering, why do I need to write this down? Save the forest and use the computer, right? Well, this just helps me to work a little bit better. I can make notes as to my findings in case I put the project away and need to come back to it another day. Alright, so let's 22 ohms each, and these are linked together, so when we're measuring across these we're going to get a different reading. Now when reading resistance and capacitance in any circuit, depending on how it's hooked up, you might get different readings because of other paths. But this path is pretty good because it's just going out to the mic, so we're going to have the mic disconnected from the circuit. Therefore, it shouldn't be giving us any false readings as we're checking these components. If I measure from here to here with my ohm meter, I should only be getting 0 ohms. If I'm getting an open circuit, then that's the problem there. If this capacitor has failed us, if it's open or shorted, that could also be a problem. So as I check from here to ground, that will tell me the story about this guy. Again, nothing will be getting in the way of measuring that. And then as I measure over here, these two, when you have two resistors together, 22 ohms each, then you have to take that number and divide it in half. So that's going to be only half of 22 ohms when you measure across from here to here. Alright, hope that explains it. Now, finding these on the board is another reason why I've written these down here, because I'm going to have to leave this page and go over down to this page. Now this is the front part of the board. We have not yet seen the front part of the circuit board. I did not take it out. But our first one is actually on here. It's R2101. And where did I see that? Ah, over here. So let's pull that into our camera view. Zoom in a little bit more. Right here. The ink is really faint on this picture, but if you can read it, it's R2101, and its position is right here on the front of the panel. So let's grab the head unit here. So okay, this is the head unit again. Now let's see. Oh, by the way, these circles over here and here are these circles here and here, the volume and the scouts. So we turn it this way, and now we know we're looking at the wrong side again, because this is the front side. So it should be this way. And we're going to find that resistor right here. And look at that, that's right next to the number 2. Or number 3 actually. Close in between the two of them. Between the 2 and the 3 buttons. Right here. You see this is button 2, this is button 1, 2, 3. 1, 2, 3. And where the drink spilled into this was around here. So that would make sense that something here in the circuit has gone bad. And it could very well be resistor 2102 right there inside here. So we have to take this out in order to get at that. I suspect it's that one. So let's take this out and have a look. Okay, camera's rolling again, and you might hear my little fan here. I use a little fan to help keep my hands dry while I work on this stuff. My hands perspire, so this fan helps me to stay cool. and you might hear that in the video a little bit. If you do, please just ignore it. Let's focus now on taking this apart. First things first, we got to pull off these buttons. Easier said than done sometimes. If you have gloves around, you may wish to use them. I get gloves like these. I get them at the local dollar shop. They help me to grip things when your hands are slipping. There's one. And there's two. Alright. And then this one here. Under this one, you're going to see a nut on there. You have to loosen that nut off. And I find the best thing to loosen that off is just simply a pair of needle nose pliers. And I got my needle nose pliers right here. So I'll just reach in there. And use what you got at home. Whatever will fit. Just knock all that off there. Now this is my radio, so I can handle it a little bit roughly. If I was working on somebody else's equipment, I'd be a little bit more delicate with it. So there we go. Okay, now let's try to remember where that resistor is here. I think, if I'm not mistaken, it should be over here. And if I look in there, it's going to be very, very tiny and hard to see which it is. In fact, I'm going to have to get a magnifying glass out and have a look at that. This is one of those times where you wish you had a microscope connected to your computer so you can just view it. So I got this little jeweler's magnifying glass. I'm just going to take it out of the camera view for a moment here and take a look at it, and I'll tell you what I see. Well, there it is. There it is right there. Okay, I'm trying to figure out a way that I could get you folks at home to see this. Now, I don't know, I've never tried this before, but it's worth a shot. I'm just going to get the light over here closer. Oops, sorry. Didn't mean to bump you guys around there. If I can just focus this in, what I seen in here, where's my pointing tool? Okay, here we go. Right down in there is exactly where we thought we would find it, and it is there. It says 0 right on it. It's a little black chip resistor, and one side of it looks like the solder has completely come right off. So cold solder joint or corroded solder joint, whatever you want to call it, it's in there. Now how can I focus my magnifying lens so that way you guys can see this, what I'm seeing here? I don't know if this is gonna, oh there we go. Okay, I'm seeing some stuff here, but I need to get back in here. Well, it's down in there. Got to get light onto this somehow. Let me just put that down for a minute. I'll try a different angle with the light. Try this angle here. So it's down in there. And you see the 0? It's the one on the uppermost right hand side. So what I'm going to do, there it is right there. Now what I'm going to do is measure it with the ohm meter, see if it's still good, and then just simply resolder it if it is still good. That would be my best case scenario. And then of course test it out. So I'm just going to try to get everything set up here, and I need to change the battery in the camera, so I will be right back. Alright, I managed to find a better way to show you the problem here. So we're looking at that 0 ohm resistor right there, and if you see the bottom solder pad, it's got a crack right through it. It's totally open circuit right there. I'm just focusing with the magnifying lens on it. And this is on the board right there. Very, very small to see it. Extremely small to solder it. But we're going to give it a shot. I got one of these head style binoculars or magnifying glasses. This is what I'm going to use to work on it, so I can see it while soldering. And not much room here for all the equipment, the camera and the soldering, so I'm just going to turn the camera off, have a go at it, and then let you guys know how it went, and maybe try to get a picture of the after solder job. Just got a very small fine point solder iron here, and try to get in there with it. If I can't do it with that, then I have a hot air one here for surface mount components. So let's see which is going to be the easiest tool for the job. And I should also mention that this is a surface mount component, so the heat setting on the solder iron should be set for about 280 degrees, which is set right here, 280 degrees. So if you don't have one of these, perhaps what you could do is measure your solder iron tip with another source of measuring. What am I looking for the word here? They have a laser temperature gun. You could use one of those also. I don't have it here right now, but I'll try to do a video on that later on. Show you other ways of setting your temperature in your solder iron if you don't have a digital display when working on small components like this. Okay, let's get this done. Thought I'd bring you guys along with me on the wild adventure of me soldering this micro size resistor. First I'm going to check it out. Make sure that it is still a good resistor. And this thing is really small. Checking my meter. The meter's working, okay. It's going to be hard for me to get in here, but I'm going to try. Ah, there we go. Okay. It's actually showing 6 ohms, but that could just be because there's some dirt on it or something, so. Again. Well, it's a 0 ohm resistor, so worst case scenario I could always just put a bead of solder across the two take care of it as well. I mean, I'm sure it does serve a purpose in the circuit. But this is an older radio, and it's a mobile radio too, so it's taken a lot of abuse. Okay, just looking in there. What I'm going to do is I'm going to try it, and if I'm not happy with the voltage that's coming out of the test point, then I will just bypass the whole thing altogether. So first I'm just going to get a little bit of solder on the tip of my solder iron there. And reach in here ever so carefully. Make sure I get enough to begin with. And reheat it. Yep, need a little bit more solder. Look at that and see. Okay, I'm back. The battery ran out in the camera, so I had to take a minute there to put in another battery. So we left off here soldering this resistor in place, and there was a bit of sloppy solder that had spilled on the board loosely, so I'm just removing it with the tweezers here. Better get back on my vision here. Okay, let's just go in and have a look, make sure that we don't have any beads of solder where we don't want them to be. Otherwise we could have a whole new problem to be troubleshooting. Okay, that looks pretty good to me. Now I'll test it with the continuity checker again. One over here, one over here. Getting a very high resistance. So yes, now this is not looking good. I think that this resistor has gone too bad to use. I'll try it again. No, I'm not happy with this at all. So what I'm going to do is I'm just going to solder a bead of solder right across there. Now I'm only going to do that because this is my radio, and if it were somebody else's radio that I was fixing, I would order the part. But because I want to get back on the air and take the chance This is a 0 ohm resistor. I don't think that it's going to be a problem if I were to just put a jumper across that. So now I'll get back in there with some more solder and solder right across it. Takes a really steady hand. Okay, I got the resistor here, it just came off. So let's get rid of that resistor. Let's have a look at those pads in there and see what condition they're in. Again, clearing off any solder that went anywhere we don't want it to be. So that resistor pretty much was a jumper across 2 terminals, and there is another line going through there, so as much as I would like to put a bead of solder across there, I can't. Instead, what I must do is use a piece of wire, very, very fine strand of wire, and make a little loop in there. So here's what I'll do. I'll find some wire, solder it in place, and then bring you guys back in to see what I've done. So I'm just taking a pause to show you guys. The board was moving a lot, so I just kind of came up with this little way of holding it in place. Just use a regular C-clamp and just very lightly just lock it in place, and the weight of this seemed to stabilize this so I could work on it a lot easier. I was taking this multi-strand wire here. Let me get a little closer here and focus the camera on it. There we go. So once I clean up the board a little bit, refresh the 2 little pads of solder that I got to jump, I tanned the 1 strand of this multi-strand wire. Tanning, for those of you who don't know, is just heating the wire and putting solder on the wire itself, getting it ready so that way it sticks a lot easier when you go to connect it to the solder pad. So now I got one side on there. Now I'm going to cut it to length. I'm going to leave a little bit of a loop in there, and then I'm going to solder the other side onto the other pad right there. So let's go back over here. I'll try to film some of this if I can get it on there. Again, not too tight. We don't want to crack anything on the board, just very loosely. Cutters, precision cutters, and I'm going to cut this wire right about here. There. So now we can get rid of this. Okay, so after maybe 20 minutes or so of working on this, I finally got this little jumper in place. Just trying to focus on it there. You can see the 2 solder pads and a little fine piece of wire going across the 2 of them there. I'll try to get it on another angle. Okay, I got it on another angle here. You can see it a little bit better, how it goes into a circular shape. It's not flat on the board because there is a line going underneath it, so I got to make sure that there's plenty of space on there. It comes up and goes around a little U shape and back down on the board just like that. And then on the back here I put a piece of electrical tape across there, so that way, just in case, you know, being a mobile radio, if that should ever move, not that it should, but just in case, the electrical tape is there so it won't short out or ground out anything. So there we go. Now it's time to hook it up and give it a test. So I'm just going to show how I put all this back together. Buttons are already in place. Screen is clean. Inside is clean. And just carefully lay this down in place like that. Turn it over. And remember, we had our washer and the nut that goes on there. Use my needle nose pliers to tighten it back up. Be very careful not to over tighten. There, that's good enough. Now there's this little part here that sits on there and goes into this knob here, so it fell out of the knob when I took it off. I'll just put this back in the knob first, then onto here, secondary, just like that. And let's not forget our volume and our squelch controls. Go on there, and this one goes on here. If you get them mixed up, it doesn't really matter because they're both the same. Alright, let's go back to doing our voltage check. Now remember, our test point here, right here, should read 8 volts, or 8.8 or 8.9, somewhere around there, if this is working. So we gotta plug this in first. This is the moment we've all been waiting for. Turn it on. We're getting 13.3 volts from the power supply. And now I'll get my voltmeter set up here. Make sure it's in camera view. Turn it on. Go to one of the grounds. Oh, I'm on the ohms from my testing. So let's go to the 20 volts DC range. And ground here. And then, okay, we know that this one was actually giving us the voltage before, so we'll double check it now. 8.7. Alright. So now we want to go over here to the red wire and the test point that is just in front of it. And look at that, 8.7. Now if I go to the red wire itself, right up here where the wire goes in, I should also be getting 8.7. And I am. Fantastic. We're on the right track. Now let's hook up our microphone and carefully plug this in over here. Let's try the red light test. And for this, we're going to put out my other lights. There you go. Look at that. Isn't that fantastic? It's nice and bright red again. And the switch is just here to control that feature off and on again. So I'm just going to put all this back together and do a audio test and also a wattage test to make sure that we're still putting out lots of wattage. Now everything is all hooked up to the dummy load here, and this is my watt meter. I'm just going to quickly just do a little test, and yeah, it's still putting out 5 watts on low power. Pretty straightforward putting back the casing. So I'm not going to film that, you guys can figure that out. And then we're going to try an audio test. Okay, so we've got everything back together now, and I got both of the radios here. This one's my little receiver radio. My transmitter radio is going to be here, and we're going to see the power output here is on low power for our test. I'm going to key it and see if it's going to work now. So here we go. There you go, fantastic, it's working. So if you have a problem with your FT-7900, or similar models, it's basically the same way of troubleshooting it as I showed you in the video. And hope you enjoyed this video. Hope you find it helpful in troubleshooting your own radios. If you enjoy the video and want me to make more like this, please comment down below, and follow the YouTube channel. Lots of fun, interesting things happening. Thanks for watching.